All right, hey guys, so I'm back at you live. I'm going to look at our FSA Warm Ups Grade 5 review packet, and I'm going to be looking at days 8 and 9. And so I'm just going to go ahead and get started. And if you're joining in a little bit later, just pick it up when you come in. So this one says solve, write your answer in the box. So I am multiplying 35 hundredths, hey Sophia, times 1 and 5/10. So technically these kind of have the same number of digits. 35 times 15 is kind of what we're going to end up multiplying, so it doesn't really matter which one goes on top, but that zero sometimes throws people off. So I'm going to write 35 hundredths on top times 1 and 5/10. And now I can just multiply this just like I would multiply any multi-digit multiplication. Just remembering that I am going to have to place my decimal at the end. This would be like 10 to the power of 2, and this would be like 10 to the power of 1. So when I get my final product, I'm going to divide it by 10 to the power of 3. All right, so now just multi-digit multiplication. 5 times 5 is 25. I would drop my 5 and regroup my 2. 5 times 3 is 15 plus 2 more is 17. And now I've multiplied by, all the digits. The 0 really doesn't count for anything. Now I'm moving into what would be my tens place. So I'm going to drop down a 0, representing I've moved on to my next place value. And I would do 1 times 5 and 1 times 3. So now I have those two partial products that I'm going to join together. 5 plus 0 is 5. 7 plus 5 is 12. So dropping down my 2 and regrouping a 1. And then 1 plus 1 plus 3 more is 5. And again, the critical piece here is that I remember that this answer is not 525. This decimal needs to be moved over 3 times. 1, 2, 3. So my answer is actually 0 and 525 thousandths. Now again, when we're estimating, I multiplied 1 and 5/10 by a number less than 1, which means my answer is going to be less than 1 and 5/10. So if I thought 5 and 25 hundredths, it would be too low. It would be too much. It has to be less than 35, 1 and 5/10. All right, so let's look at the next one. The next one says, what is the value of 1/10 of 5 and 4/10? Shade the model to represent the value. So if I want to find a tenth of 5 and 4/10, the easiest way to remember is a tenth of is talking about place value. How many times would I move over my decimal? And since there's 1 0, you're going to move it over 1 time. And since they're multiplying by a number less than 1, you should know it needs to be getting smaller. So it would be that as your answer, 0 and 54 hundredths. If you didn't recognize that, you could multiply it 1/10 times 5 and 4/10, and you would get 5 and 4/10 divided by 10. And when I'm dividing by 10, 5 and 4/10 divided by 10, you're going to end up with the same business. It's still going to equal this. It really doesn't matter how you come about it. But as far as what does that look like with the picture model, 54 hundredths, you would have shaded 10, 20, 30, 40, 50. And then 4. That shows 54 hundredths. Now I'm going to move on to my next question. My next question, number 35. A community center has 3 swimming pools. The water in each pool, hey Tavia, the water in each pool is, oh, good to know, Sophia. Yay! I'm so happy. Awesome. The water level in each pool is measured at 8 p.m. each night. 2 of the measurements from the Saturday night is shown.
Mommy.
Hold on, guys. I'm going to mute this for a second if I can figure out.
I want orange juice.
You want orange juice. You're going to have to wait for your orange juice.
I'm gonna wait.
Do you guys hear my daughter? She's gonna wait. She's gonna wait for her orange juice. Okay. Anyways, so the water level in the first pool is 3 and 5/12 feet deep. The water level in the second pool is 4 and 3/8 feet deep. So part A wants to know what is the difference in depth between the water levels in the second pool and the first pool in feet. So if I'm wanting to find difference, I'm going to be doing subtraction. I'm going to be subtracting 4 and 3/8 minus 3 and 5/12. So there's not a lot of room on that paper for me to show my work. I mean, I guess I could, but I'm just going to get a separate sheet paper. So I'm going to show my work on this piece of paper, and I'm subtracting 4 and 3/8, and I'm going to find the difference between that one and the other one. Oh, it froze. All right, so I don't know what happened, but I froze, so I'm back at it. Anyways, so we're trying to find the difference for question 35 between the two pool depths, 4 and 3/8 and 3 and 5/12. And so I know that when I am adding or subtracting fractions, I have to have a common denominator. So I need to figure out what would be my common denominator for 8 and 12. If I don't know that right off the top of my head, I can list my multiples for 8, list my multiples for 12. So 8, I've got 8 times 2 is 16. 8 times 3 is 24. Times 4, bye, see you tomorrow, bye girl. Times 4 is 32. And then do my multiples for 12. I've got 12, 24, 36. And when I look for the least common multiple, it's 24. So I'm able to create common denominators with equivalent fractions, common denominators of 24. So here I want to figure out what did I do to go from 8 to 24. In which case 8 times 3 is 24. So I would do, hey Chloe, do the same thing to my numerator as well. And I would get an equivalent numerator of 9. And here, what did I do to go from 3 to 24? I mean, 3 to 12. From 12 to 24, which is I multiplied by 2. And so now I have 10. So I'm subtracting. Chloe, we are on question number 35 if you're joining. I have 4 and 9 24ths, and I'm taking away 3 and 10 24ths. And hopefully you recognize I cannot do 9 minus 10. So since I can't, I'm going to regroup from my whole. And that one whole that I'm borrowing is going to get added in with my 9. So the whole will be whatever your denominator is. In this case, it's 24. 24 24ths is your whole. So 9 and 24 means I now have 33 24ths, 3 and 33 24ths. Take away 3 and 10 24ths. And when I take those away, I get 3 and 23 24ths. That's my answer for part A. Check. Part B says the water in the third pool is 2 3/4 feet deeper than the water in the second pool. What is the total depth of water in the third pool in feet? So, second pool, that information was right here. That second pool, I'm just going to kind of jot it so I don't forget what I'm working with. All right, so that was the second pool. Check, second pool. The water in the third pool is deeper. Oh, so since it's deeper, bye Chloe, since it's deeper, I'm going to be joining together the 4 and 3/8 plus the 2 3/4 feet deeper that it is. And when I'm adding these together, I know that, again, when I add, I have to have a common denominator for 4 and 8, which means I could add both of them, and I'm going to erase this because I'm just going to show my work right there. I have all the space in the world right there. Good to go. I'm going to rewrite these with common denominators of 8. This one already in 8, so I'm just going to bring it across. But here, what did I do to go from 4 to 8? I multiplied by 2. So here your equivalent numerator would then be 6. So now add together 3 eighths plus 6 eighths. You've got 9 eighths. And then add together your whole, 6 and 9 eighths. But what do you notice about this fraction? Hopefully you notice that you have an improper with a mixed number. You cannot have that fraction, so you need to regroup. Add in one more whole, which means you took away 8 eighths. So now you have 7 and 1/8. So now let's move into day 9. Day 9 says 12 pounds of beans are distributed equally into 8 bags to give out as food. How many pounds of beans are in each bag? So I've got 12 pounds and I'm splitting it equally into 8 bags, which means I am dividing 12 divided by 8. And guys, we've talked about this. That's the same thing as a fraction. 12 eighths. And then I want you to take that and simplify that. And I'm going to have you do that part on your own, regroup it into a mixed number, and then create a lesser equivalent fraction. Take a moment and do that. Hopefully you recognize that 8 can go into 12 one time, which means I would be taking away 8 eighths, and I would have 4 eighths left over. And then again, what do I know about 4 eighths? 4 eighths is equivalent to 1/2. So 1 and 1/2, check, boom. Here, Kurt drew a rectangular maze with a length of 3/4 and a width of 5/12 foot. What is the area in square feet of Kurt's house? And again, what do I know about area? Area is length times width. So you're essentially multiplying. You're doing an area model is really what you're doing. And how do I multiply fractions? Hopefully you know this because we did it today in class. Numerator times your numerator. Denominator times your denominator. Now, the question is, can these be reduced? I know this can be divided by 3 and 15. So I wonder, can 48 be divided by 3? Let's see. 4 can go into 3 one time, which would leave 18. Oh, yep. It can go in 16 times. So they could both be divided by 3. So this would also be equivalent to 15 divided by 3 would be 5, and 48 divided by 3 would be 16. And this is the answer that I'm actually looking for. Okay, look at number 38. Which equation shows a correct product? So when I multiply them, are they correct? And again, when I'm multiplying by powers of 10, it's really talking about 10 times greater or 10 times less, moving over that decimal. Here you're multiplying by a number greater than 1, so you know it needs to be getting bigger. And how many times is that decimal moving over? Brooklyn Marie, you hear this, girl? Brooklyn Marie, stop jumping on my bed.
Yeah.
All right. In this instance, it's going to move over one time, which would put it between the 6 and the 2. So does A work? No, A does not work. Look at B. B moves over again how many times? Does B work? Nope, B does not work. Look at C. C moves over 2 place values 2 times, 10 times greater, now 100 times greater. It would be at the end of the 9. Does that work? Yes, it does, because if I made it math magical, I would drop that decimal at the end of the 9, and all I'd be left with is the 9. And here I'm moving it over 3 times. 1, 2, 3. Does D work? No. Okay, look at number 39. Adam has a half a quart of milk. If he pours the same amount of milk into 3 glasses, how many quarts of milk does he have? Now, don't be confused. I'm going to pause this, guys. Don't be confused. This is not a conversions question because these are both talking to you about quarts. So there's no conversion. Really, I'm just taking the half and I'm dividing it into 3 glasses. So 1/2 quarts divided into 3 cups. And again, when we do fractions, it's always going to be keep, change, flip. What's the reciprocal of 3 whole? The reciprocal of 3 whole is 1/3. And now multiply your numerators, multiply your denominators. If I took a 1/2 quart of milk and I split it into 3 equal glasses, everybody's going to get 1/6 of a quart of milk. Oh, duh, quarts was already labeled. See, that's what I get for looking into my phone. And the last question. A builder has an 8-acre plot divided into 1/4 acre home sites. How many home acres does he have? So you could envision like, or you could even do this in number line. It's probably easier even with the number line, to be honest with you. 4, 1, 2, 3, 4. Okay, so those are my acres, and each of the acres is divided into a 1/4. So that means it's divided into 4 equal parts. And now you would look, how many plots do you have? This is the same thing as saying 8 times 4. I cut it into 4 parts. Again, 8 divided by 1/4, keep, change, flip would be 8 times 4, which means I now have 32 home sites or 32 plots. And that is it for tonight. If you have any questions, please leave it in the comments. If you want to get ahead for tomorrow, please continue on to day 10. Have a great night, and I'll see you all tomorrow.